Welcome to this platform. So in this video, let us cover one of the topic in mathematics called indices. So this topic, if you're writing GCE, also school certificate, ECZ exams, this is one of the topic that you need to prepare or that you need to learn for you to prepare for paper 1 exams. All right, so we are going to cover the topic in full, and of course at each point we should be able to answer questions from the exams. All right, so I urge you to stay up to the end of the lesson. So the topic that we are going to look at, indices. We are going to look at indices. To start with, we need to understand what indices are. So for indices, it's just an expression of a base to the given power. So when you look at indices, we are looking at the expression of the base, let us say the base b, to the given power, let us say the power n. So this is called the power or index, and of course this is the base. So this is what we call indices. That is what you're going to look at. Now, to understand this topic, there are rules that we need to follow. So we need to look at rules of indices or laws of indices. What are they? What are the rules of indices? So the first one that you need to know is that any number raised to the power 0 or anything raised to the power 0 is equals to 1. Any number raised to the power 0 or anything raised to the power 0 is equals to 1. For example, let us have a number 100 raised to the power 0. This is equal to 1. That is one of the rules that you need to know. All right, let us put another one. Let's say x raised to the power 0. This is still 1. Y raised to the power 0 is still equal to 1. Z raised to the power 0 is equals to 1. And this is the reason why we are saying the first rule states that anything raised to the power 0 or any number raised to the power 0, the answer is equal to 1. So that is the first one that you should know. Okay, let us have a look at the second one. So for the second one, we are going to look at anything raised to the power 1. Anything raised to the power 1 is itself. Any number raised to the power 1 is the number itself. Any variable raised to the power 1 is itself. In other words, we are saying, let us say 100 this time around raised to the power 1. The answer is 100 and not 1. Let us say x to the power 1 is equal to x. Okay, sometimes we just write it x. You should know that it has the power 1. If you cannot see the power, just know that it has the power 1. Then of course, let us say y to the power 1 or just y is equals to y. Z to the power 1 is equals to z. So this is the second one that you need to know. Anything raised to the power 1 or any number raised to the power 1 is the number itself. Then the third rule that we can look at is called the product rule. What does it state? Look at this one. We are going to say, given that a to the power m multiplied by a to the power n. In this case, this is just going to be a to the power m plus n. This applies only and if only the bases are the same. So this applies only if the bases are the same. So for the power rule, it says, when you are multiplying a number of same bases, the power adds. Okay, I guess you've gotten that. For example, 2 to the power 3 multiplied by 2 to the power 2. In this case, it is going to be 2, that is 3 plus 2, which gives us 2 to the power 5. 2 to the power 5 is just 2 multiplied by itself 5 times. 2 multiplied by itself 5 times, and therefore the answer is 32. So 2 to the power 3 multiply 2 to the power 2. The bases are the same, the powers add. So please don't confuse this. Only when you see multiplication. If you are seeing addition, division, and any other signs, you do not, or this one does not apply. Only if you have multiplication. All right. Let us have one more example. Let us have 4 to the power. So this is example 1. This is example 2. 4 to the power 2 multiplied by 2 to the power 3. So now, here you need to know that 4 and 2 are the bases, and of course they are not same, or they are not equal. So for us to apply the power rule, we need to express to the same base, and normally follow the small base. So in other words, we need to express 4 to base 2, or to the base of 2. Now, how do you do that? Now, you need to know that the power, it simply shows how many times you multiply the number by itself to give you a number. So in this case 4, what number can we multiply by itself to give us 4? You find this 2. So 4 can be written as 2 to the power 2. And of course, brackets, outside there's a 2. Then of course, multiply a 2 to the power 3. Okay, we are going to look at another rule of which you multiply the powers. So in other words, 2 is going to be 2 multiplied by 2, then multiply by 2. I've just multiplied this, okay, to the power 3. This is going to give us 2 to the power 4 multiplied by 2 to the power 3. We just add the powers, and we are going to have 2 to the power 7. 2 to the power 7 is the number that you multiply 2 7 times. What is the value? So 2 multiplied by 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 2. What is the number that we are finding? Be able to comment the answer that you found. All right, we proceed to the next one. So the other one that we can look at, the fourth rule that we can look at, is what we call the quotient rule. Okay, so this one is called the quotient rule. Okay, so for the quotient rule, for you to find the quotient, you must have divided the numbers. All right, so now in this one, we are going to say, given that this time around we are given, let's say, a to the power m, the same one, but the difference that this time around you are dividing a to the power n. How does this one become? So this one, on this quotient rule, when you are dividing same bases, you subtract the powers. So it is going to be, when you are dividing numbers with same bases, please, the powers, subtract. So this one is going to be m minus n. All right, so that is what happened. Let us look at an example. This time around, let us say 3 to the power 4 divide 3 to the power 2. This one is going to become 3, 4 minus 2, and it becomes 3 to the power 2. 3 to the power 2 is 3 times 3, and this is equal to 9. So that is how you apply the quotient rule. Let us have one more example. So for another example, we can say, let us have 2 to the power 5 divide 8 to the power 2. Okay, so for us to apply this rule, we need to express this in the same base, and I said you follow the small one. So we are going to express 8 in as a base 2. So how do you do it? So 8 is just the same as 2 to the power multiplied by 2 multiplied by 2. 2 multiplied by 2, that is 4, multiplied by 2, that is 8. So 8 is just the same as 2 to the power 3. So we are going to say 2 to the power 5 divide 2, and of course outside there is inside there's to the power 3 multiplied by 2. So this is just the same as 2 divide 2, then of course to the power 6, because 2 times 3 is equals to what? 6. This is to the power 5, please. Now what happened? You're going to have 2, 5 minus 6, which gives us 2 to the power negative 1. As you know, you get the smaller number, subtract from the bigger number, maintain the sign of the bigger number. So in this case, this one, we are going to look at another rule. Okay, we are going to look at another rule soon, but this one is just the same as 2 to the power 1, which is just the same as 1 over 2. Okay, 1 over 2. So that is how you can look at it. But most importantly, you need to know that when you are dividing numbers with the same bases or letters with the same bases, just know that the powers subtract. Very important to know that. Okay, let us have a look at another one. Let us have a look at another one. This time around, we are looking at the power rule, what we call the power rule. What about this power rule? So generally, if you are given a to the power n, and of course outside to the power m, what this means, or applying the power rule, it gives us a, the power multiplies, so n multiplied by m. Okay, so if the power is raised to the powers multiply. So therefore this one is going to be a n m. Very important to know this. Let us have a look at an example. In this case, let us have a look at an example. So an example that we can have, let us say 4 to the power 3, then raised to the power 2. So in this case, this one is going to be 4 to the power 6, okay, which is the 3 multiplied by 2, the powers multiply. And 4 to the power 6 is just 4 times, multiply 4, 6 times. Okay, so 4 multiplied by 4, multiplied by 4, multiplied by 4, multiplied by 4. The answer that you find, that is 4 to the power 6. All right, I guess you're following up to this point. All right, let us have a look at another example. 3 to the power 2, then of course the power half. The powers still multiply, so you're going to have 3, 2 multiplied by 1 over 2. Okay, these are reciprocal of each other, so they cancel, and of course this side, and you are going to have 3 to the power 1, which is just the same as 3. Up to the next one, which is the number 6 in this case, and this one is called the inverse rule. Okay, what about this inverse rule? So in this case, we are going to say, given that a as a base, then raised to the power negative n. This is just the same as a raised to the power n. So we put this one 1, then the negative goes. Okay, so inverse rule, when you have the number, okay, that is a, the base, raised to the power negative, so you just write it in this form and it becomes positive. So 1 over a to the power n. Okay, let us look at this one. One example. So let us say a raised to the power negative 2. This is just the same as 1 raised to the power 2 to the power 2. Okay, this is just the same as 1, 2 to the power 2, which is just the same as 1 over 4, because 2 to the power 2 at the bottom is just 2 times 2. All right, one more example. Let us say 3 to the power 3 to the power negative 2. Okay, this is just the same as 1, 3 to the power 2, which is 1, 3 multiplied by 3, which is just the same as 1 over 9. Okay, now listen very carefully, which means when you are given the number such as 1 over 9, you can express it to base 3, and of course with a negative 2 on top. Okay, so 9 is just the same as this one. Very important to take note of this as we go on, as we start looking at questions you are going to see. All right. Let us look at now what we call the fractional power rule. What about the fractional power rule? So, fractional power rule. What about the fractional power rule? So, for the fractional power rule, in this case, let us say we are given, given that A, which is the base, n over m. So when you are given a number raised to the power of which the power is a fraction, how do we write this one? So this one, this on top is the power, and of course this one is the root. What do I mean? So this is written as A, then m, of course, the power n. Okay, so that is how you write it. Let us look at an example. So if you have, let's say, 9, 3 over 2. Okay, how can we express this one? So it is going to be like this, then 9, then of course 3 as a power. Now, even if we don't put a 2 here, this just means the square root of 9. Now, the square root of 9 is the number that we can multiply by itself to give us 9, and that is 3. So the square root of 9 in the bracket inside here is 3, but to the power 3. 3 to the power 3 is 3 multiplied by 3 multiplied by 3, which is 27. Okay, so 3 over 2, 9 to the power 3 over 2 is 27. I don't know if you've gotten this. Let us have a look at another one. What about if it was the second example? What about if it was, let me put 9, then of course this time around -1 over 2, if it was like that. What was going to happen here? So you know that this is supposed to be written as 1 over 2 as positive. So now to find the value of this, we are going to write it this way. Remember, on top there's 1, but the bottom part here is 2, which is 9, and of course to the power 1, which is just the square root of 9. So in this case, it's going to be 1. The square root of 9 is 3. So this one ends here. You see the difference? All right, one more question, maybe on this one. Let us have a look at maybe, which one? 27. Okay, 27. Then we have square. Let me put it negative, then 3. How is this one going to be? So for this one, it's going to be 1, then 27, 2 to the power, to the power 2 over 3. All right, so we are going to continue to 1. Then the bottom part, what is the root? So the third root of 27, then of course everything to the power 2. So in this case, it is going to be 1 over cube root of 27 is 3. So the number that you can multiply 3 times to give 27 is 3. 3 times 3 times 3 is 27. Now, the whole of this one is to the power, the bottom part is to the power 2. All right, so this is going to be 1 over 9. Okay, I guess I've gotten it right. All right, what about if we had, this is the third or the fourth example that we are looking at. What about if you have 16 over 81, then to the power, let me start with 2 over 4. 2 over 4. How is this one going to be? So for this one, look at this. We have the fraction now as the base. How is it going to be? So this power is shared on the denominator, the numerator and the denominator. So this one is going to be 16 over 81 to the power 2 over 4, then 2 to the power 2 over 4, 81 to the power 2 over 4. This one is just simply going to be the root on top of 16, then of course the fourth root on top to the power 2, then also at the bottom we are going to have the fourth root of 81, but of course to the power 2. So how is it going to be? What is the fourth root of 16? So the fourth root of 16, we are looking at the number that we can multiply by itself 4 times to give you 16. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So therefore the number here is 2. But of course remember to the power 2. Divide. At the bottom, the number that you can multiply 4 times to give you 81 is 3 times 3 times 3 times 3. So at the bottom is 3. But of course to the power 2. So how is this going to be? It's going to be 2 to the power 2, then 3 to the power 2, which is just the same as 4 over 9. So that is the answer. I guess you've seen it. Now, this one, it was positive. Let us look at now when it is negative. And we are going to say, this is example number 5. So in this case, we are saying 16 over 81 to the power negative 2 over 4. How is this one going to be? So to start with this one, you put a 1 on top. Then of course you write 16 over 81. And of course to the power 2 over 4 become positive. Alright, we continue. So this one is going to be 1 over 16 to the power 2 over 4 divide 81 to the power 2 over 4. How is this one going to become? So 1 over the root of the fourth root of 16, the power 2 divide the fourth root of 81 to the power 2. And this is going to become 1 over fourth root of 16, that is 2 to the power 2. Okay, divide 81, that is 3 to the power 2. And this is going to be 1 over 4 over 9. Okay, now at this point, what do you have? At this point, you have 1, is that the same as 1? Divide 4 over 9. Now you know when you are dividing what happened. You reciprocate. So 1 over 1 multiplied by 9 over 4. And this is going to be 9 over 4. And that is the answer. I guess there's no confusion. Okay, so the thing that you need to know is that you just need to know that to remove the negative, you put a 1 over the whole of this one with a power positive. Then of course, you know that this power is shared, the denominator and the numerator, and therefore it is going to become like this. Then of course the fourth root of 16, which is 2, the fourth root of 18, which is 3, to the power 2 to the power 2, which is 4 over 9. Then of course you are dividing, you reciprocate. In other words, the denominator becomes the numerator becomes the denominator. And that is how we simply answer this one. Okay, I guess you're following up to this particular point. Okay, I guess we are following up to this particular point. Okay, having looked at all the rules that we've looked at, and of course we have learned something that we can use maybe to look at another part of this topic, that is equations involving indices. So equations involving indices. How can we answer equations involving indices? So the first example that we are going to have, example 1. So let me say examples. Example A, we are going to have the equation such as 3x is equals to 3, 0. All right. Now, when you are solving such equations, you need to make sure that the bases on both sides are equal. And if the bases are equal, then of course the powers are equal. So in this case, x is equals to 0. That is the answer. Let us look at another one. So if we have 3, let's say x minus 1 equal to 9. Okay, so the principle, we need to make sure that the left hand side and the right hand side, they have same bases. Okay, we ensure that the bases on the right side, this is the right side, and of course the left side in relation to the equal sign are equal. So here we have the base 3, x minus 1, and since 3 as a base is smaller, we are going to convert 9 where it has the base 3. So 9 to base 3 is going to be it's just the same as 3 to the power 2. 3 to the power 2 is 3 times 3, which is just the same as 9. So now that the bases are the same, we have 3 and 3. We can say x is equals to, x minus 1 is equals to 2. In other words, we equate the powers. So what is going to happen? X is equals to 2 plus 1. And therefore, x is equals to 3. So that is how we can find this one. Have you got anything here? Let us look at one more example. This is the third example that we are looking at. Let us say we have 9, 2x minus 2 equal to 27 negative 2x. Does this one appear complicated? So equally here, you look at expressing, or the thing that you need to express the bases on both sides to be common. Okay, so bases on the on both sides should be equal, on the right side and on the left side, I mean. So now it finds that 9 and 27, they have nothing in common in terms of we cannot say the common base here is 9, because 27 cannot be raised to 9. The base 9. So now we need to find the one that we can now put less than 9. So in this case, on both sides, we can say 3. 9 is just the same as 3 to the power 2. Okay, so 9 I've expressed as 3 to the power 2. But remember, outside there's x minus 2. Then equal to 27. Also, if we are to put base 3, it is going to be 3 to the power 3. But remember, on top there's negative 2x. Okay, so now applying what we call the power rule, power raised to the power multiplies. So we have 3 on top, we are going to have 2x multiply negative 2 multiply 2x negative 2 equal to 3 multiplied by negative 2x. So now the bases are the same, so we can equate the powers. So 2x minus 2 equal to 3 negative 2x. This side we are going to have a 4x minus, this is a 4. Okay, then this is equal to negative 6x. We collect the like terms, so 4x minus or plus 6x. Then of course this one goes the other side, which is plus a 4. So this is a 10x equal to a 4. Divide 10, divide 10. Therefore x is equals to 10 divide 4 in simplest form is 2 into 4 is 2. 2 into 10 is 5. So the answer therefore is 2 over 5. I guess you've seen this one. Let us have one more example that might appear also to be complicated, but of course, please, we just apply the same concepts. Let us have the fourth example. Should be the fourth example. I've forgotten the numbers. So 4 to the power negative x minus 1 equal to 1 over 16 to the power 3 x. How can we solve this one? If the equation is solve the equation. So now we need to express the bases should be the same. So how do we do it? So you're going to check. Here the base is 4. Here is 1 over 16. That is 1 over 16 to the power x, 3x. Now you know that 1 over 16 can also be written as 16 negative 1. So in other words, this whole can be 16 negative 3x. Okay? You remember this? So 1 over 16, 3x. So now 4 negative x minus 1 is equals to 16 negative 3x. We express this, the common base. So 4 is common here. So 16 can be expressed to the base 4. So 4 negative x minus 1 equal to 4. 16 is just the same as 4 to the power 2. But of course there's a power 3x. So you're going to have 4 negative x minus 1 is equals to 4. This 2 multiplies the power. The power 2 multiply the power negative 3. X is going to give us negative 6x. So now the bases are the same. We are going to say negative x minus 1 is equals to negative 6x. So we collect the like terms. X plus 6x equal to 1. So this is 5x equal to 1. And of course divide 5. Divide 5. X therefore is equals to 1 over 5. I guess up to this point you are following. Are you following up to this point? Or maybe I've missed it somewhere. Have I missed it somewhere? Okay. So please, you should be able to follow and see if I've missed it somewhere. Alright. Then now, let me give you some more work to do. So this is your task that you're going to answer. Questions that you're going to answer, we have A or 1. So practice this. 81 over 16. 81 over 16. Then of course the power 1 over 4. Plus 81 over 16 to the power 0. The second one that you're going to answer is 81. That is 4. Of course to the power 3. What is the answer? Then of course I'll put also the equations. Solve the following equations. So solve the following equations. So we have 2x minus 1 equal to 16 negative 2x. What is the answer? That is for A or 1. 2. Let us say 125 to the power x is equals to 1 over 5. Then of course the number 3, we have 4 to the power x equal to 16 to the power 4. Let me give the fourth one, because I want you at the end of it, you are able to, if you can answer these questions, then you have no problem with the exams. So that is another one. Then let me give the fourth one. Is it the fourth one? 10 to the power x is equals to 0.0001. So take this work seriously. Then the fifth one, number 5, 3x plus 3 is equals to 27 to the power, let me say to the power 2. So please, these questions, if you are able to answer these questions, then you have no problem on this particular topic. Have you found this lesson useful? Okay, so if you found it useful, don't forget to subscribe to this YouTube channel share to many, especially those that are writing exams soon. So make sure that you share with your family and friends. But if you are interested for online lessons, that is in mathematics, chemistry, physics, biology, and that is physics, chemistry, biology, and mathematics, you can contact the number 0976 402563. So we have both online and physical lessons. If you stay near Kabwata, that is in Lusaka, you can come through near Kabwata Primary School. That is where we are located. Come and revise with us or learn with us, and I can assure you, you never regret. Otherwise, we can end here and see you in the next one.